Hello friends, in today's session we are going to see all the remaining topics in the chapter exploring java.lang package. So we will start with thread group. We have already seen the thread group, how to create thread group in the multi-threaded programming. The thread group creates a group of threads. Two constructor formats are thread group, string group name, thread group parent object, string group name. For both the formats, group name specifies the name of the thread group. The first version creates a new group that has current thread as its parent. Okay. The parent is specified by parent object in the second format. In the first format, parent object is not specified. In that case, the current thread as its parent. The non-deprecated methods we will see in next table. Thread groups offer a convenient way to manage group of thread as a unit. This is particularly valuable in situations in which you want to suspend and resume a number of related threads. Okay. So when there is a group of threads, all threads are interrelated, and in that case, you may want to suspend and resume number of related threads. Integer active count. This is the method returns the number of threads in the group plus any groups for which this thread is a parent. Okay, so it will give the total number of count. Then integer active group count returns the number of groups for which the invoking thread is a parent. Okay, active means invoking thread is a parent. Final void check access causes the security manager to verify that the invoking thread may access and or change the group on which check access is called. Then final void destroy destroys the thread group and any other child group on which it is called. Enumerate thread group array. The threads that comprise the invoking thread group are put into the group array. Integer enumerate thread group boolean all. The threads that comprise the invoking thread group are put into the group array. If all is true, then threads in all subgroups of the thread are also put into the group. Then integer enumerate thread group array. The subgroups of the invoking thread group are put into the group array. Integer enumerate thread group array boolean all. The subgroups of the invoking thread group are put into the group array. If all is true, then all subgroups of the subgroups and so on are also put into the group. Okay, so it will give you the hierarchy. If all is true, then all subgroups of the subgroups and subgroups of the subgroups and so on are also put into the group. Final int get maximum priority returns the maximum priority setting for the group. Final string get name returns the name of the group. Final thread group get parent returns null if the invoking thread group object has no parent. Otherwise, it returns the parent of the invoking object. Final void interrupt invokes the interrupt method for all threads in the group. Then final boolean is daemon returns true if the group is in a daemon group. Otherwise, it will return false. Boolean is destroyed returns true if the group has been destroyed. Otherwise, it returns false. Void list displays information about the group. Final boolean parent of thread group returns true if the invoking thread is a parent of the group or group itself. Otherwise, it returns false. Final void set daemon boolean is daemon. If is daemon is true, then the invoking group is flagged as a daemon group. Final void set max priority integer priority sets the maximum priority of the invoking group to the specified priority, to that of specified integer priority. String to string returns the string equivalent of the group. Void uncaught exception thread throwable e. This method is called when an exception goes uncaught. Then demonstrate the thread groups example. New thread extends thread boolean suspend flag. Okay, so we have already seen the suspend flag example as the last example of multi-threaded programming. If you want to revise, you can go back and revise it. New thread string thread name thread group tg object super tg object thread name system.out.println new thread. This suspend flag is equal to false. Start the thread. This is the entry point for the thread. Public void run try for integer I is equal to 5, I greater than 0, I minus minus. Okay, so what we are doing in this case, we are first of all calling super to call the constructor of the basic class, that is thread class. Then new thread we are displaying, then suspend flag is equal to false. Then we are starting the thread. We are calling start by itself because this class itself is a thread because it's extending thread class. It is not implementing the runnable method. If it would have been implementing the runnable, what we have to do? We had to create a thread object and then we had to write thread object dot start. Now here this is a implemented method, overridden run method. For 5 times what we are doing, get name of the thread. Okay, we don't have to pass the object name dot get name because this class itself is a thread. Plus I thread dot sleep 1000. One for 1 second this will sleep and synchronize this. Okay, so we are calling the synchronize block. While suspend flag we have to wait, and then if it is having exception, it will give you exception in this get name, that is particular thread. Then get name exiting, this particular thread is exiting. Then two methods written over here, void my suspend, void my resume. Suspend flag is equal to false, notify. Okay, if you will call my suspend, this will become true, otherwise it will become false, and then notify. Then thread group demo, public static void main. Thread group A is equal to new thread group A. Then thread group B, new thread group B. New thread object1, new thread 1 group A. Okay. So now 2 group A, 3 group B, 4 group B. So for group A there are new threads object 1 and object 2, 1 and 2. For group B there are 2 threads 3 and 4. So now group A dot list will give you thread 1 and 2. Group B will give you list of 3 and 4. Then suspending group A. So thread TGA is equal to new thread group A dot active count. Okay. So how many threads in this list are active? Those count will be written. Okay. So this count will be your current size of the array of thread. Then group A dot enumerate. Okay. So get threads in a group. For this particular TGA dot length thread group array, that is the active group array, what we are doing, this all threads we are suspending. Okay. Then thread dot sleep 4000, 4 seconds our thread will sleep because we are having 4 threads, 1, 2, 3 and 4. Then interrupted exception, main thread interrupted. Resuming group A, TGA dot length I plus plus, new thread TGI dot my resume threads in a group. Wait for threads to finish. OB1 dot join, OB2 dot join. So what is OB1 over here? OB1 is a thread of 1, thread 1, object of thread 1. This is object of thread 2. Okay. Then object 3 dot join, object of thread 3, object of thread 4, and exception in main thread. Okay. So all the things are same. Only thing different is that in the multi-threaded programming we have more particularly seen about the threads, and here we are seeing about the thread groups. Okay. Then new thread. Thread 1 5 group A, 2 5 group A. Okay. So this is the thread name, this is the priority, and this is the group to which this thread belongs to. So this way 4 threads are implemented and displayed. Okay. This is a sample output and this sample output may differ. Okay. So now here is the output from list java.lang thread group name is equal to group A, maximum priority is equal to 10. Thread 1 5 group A, thread 2 5 group A. Then java.lang thread group B, maximum priority is equal to 10. Next 4 3 4 3 4 3 4 resuming group A. Okay. So this is the sample output. waiting for threads to finish. 1 5 2 5 3 1 4 1 1 4 2 4 3 exiting 4 exiting. Okay, so it is displaying the thread name, its priority, okay, and active thread count as well. Okay, here it is showing you the active threads count. Okay, so next 1 3 2 3 2 1. So after join is called, all 5 times iteration is done and they are displayed one by one, and after all threads execution is finished 5 times, first of all 1 will exit, then 2 will exit, and then main thread will be exited. Okay, thread group A is suspended for 4 seconds as the output confirms. This causes threads 1 and 2 to pause, but threads 3 and 4 continue running. After 4 seconds, thread 1 and 2 are resumed. Okay, and how thread group A is suspended and resumed, we have already seen. Threads in group A are obtained by calling enumerate on group A. Okay, one by one, all the threads are suspended by iterating through each of them in the resulting array. To resume the threads in A, the list is again traversed and each thread is resumed. One last point. This example uses the recommended approach to suspending and resuming threads. It does not rely upon the deprecated methods suspend and resume. Okay. What is the main point of this? We have already seen that suspend and resume are deprecated, and in this example of thread group, we have not used those deprecated methods. Thread local and inheritable thread local. Two additional thread related classes, thread local and inheritable thread local. First class is thread local. This is used to create thread local variables. Each thread will have its own copy of the thread local variable. Inheritable thread local creates a thread local variable that may be inherited. Package. Package encapsulates version data associated with a package. Package version information is becoming more important because of the proliferation of the packages and because the Java program may need to know what version of package is available. The methods defined by package we will see now. Okay, why we require the package information? Because proliferation of the packages and because the Java program may need to know what version of package is currently available. Now we will see the example of package, and in this we will display the packages about which program is currently aware. So packages array we have created. Then for integer I is equal to 0, I less than packages dot length, I plus plus packages dot get name. So this much packages dot get packages will return how many packages are there into this packages array, and for this particular packages length, what we are doing, we are getting the package name plus get package implementation title, then get implementation vendor, get implementation version. Okay, so all the details regarding the package implementation version, vendor, title, and name. All information is displayed using system.out.println in the for loop. Now we will see the exam methods available. A extends annotation. A get annotation, class A annotation type, returns an annotation object that contains the annotation associated with the annotation type for the invoking object. Annotation get annotations returns all annotations associated with the invoking object in an array of annotation objects. Returns a reference to this array. Annotation get declared annotations returns an annotation object for all the annotations that are declared by the invoking object. Inherited annotations are ignored. String get implementation title returns the title of the invoking package. String get implementation vendor returns the name of the implementer of the invoking package. Get implementation version returns the version number of the invoking package. Get name will give the name of the invoking package. Then static package get package. string package name returns a package object with the name specified by the package name. Static package get packages. This will return an array, returns all packages about which the invoking program is currently aware. Then get specification title returns the title of the invoking package's specification. Get specification vendor returns the name of the owner of the specification for the invoking package. Get specification version returns the invoking package's specification version number. Integer hash code returns the hash code for the invoking package. Is annotation present returns true if the annotation described by annotation is associated with the invoking object, otherwise it will return false. Boolean is incompatible with string version number, throws number format exception, returns true if version number is less than or equal to the invoking package's version number. Then Boolean is sealed, returns true if the invoking package is sealed, returns false otherwise. Boolean is sealed URL returns true if the invoking package is sealed relative to URL, returns false otherwise. String to string returns the string equivalent of the invoking package. So these are the methods related to package. Okay. Now we will see runtime permission. It relates to Java security mechanism and is not examined further here. Okay, so it directly relates to your Java security mechanism, and since it is a confidential one, it is not examined over here. Now throwable class. The throwable class supports Java's exception handling system and is the class from which all exception classes are derived. Okay, so this is very important class. It is discussed in the upcoming session. Security manager is a class that your classes can subclass to create a security manager. So what does this mean? You will create a class, your separate class. For example, class my class. You will extend the security manager, extend security manager class, and your class will become a security manager. But generally, you don't need to implement your own security manager. If you do, you need to consult the documentation that comes with your Java development system. Then stack trace element. The stack trace element class describes a single stack frame, which is an individual element of a stack trace when an exception occurs. Each stack frame represents an execution point which includes such things as the name of the class, the name of the method, the name of the file, and the source code line number. Okay, so each stack frame will have this separate information about like name of the class, name of the method, name of the file, and source code line number. An array of the stack trace elements is written by the get stack trace method of the throwable class. Okay, so this method is not new to us. We have already used this get stack trace element. When handling the exception, what we do? We create a catch block. Okay, in that catch block, what does we write? We write exception E. And when we want to print the complete stack trace, so complete stack trace, how we will write? Exception object E dot get stack trace. And what this will return? This will describe a single stack frame in which individual element of a stack trace is displayed. Okay, this stack frame represents the execution point whenever error is occurring, exception is occurring, name of the class, name of the method, name of the file, and source code line number where the exception has occurred. Has one constructor, string class name, method name, file name, and line. The name of the class is specified by class name of the method is specified by method name of the file is given by file name, and line number is passed in line. If there is no valid line number, use a negative value for the line. Okay, value of -2 for line indicates that this frame refers to a native method. Okay, if you are having the -2 at the line number, you are having a native method in your Java particular application. The method supported by stack trace element, we will see this method give you programmatic access to stack trace. Now, boolean equals returns true if the invoking stack trace element is the same as the one passed in object, otherwise it returns false. Then get class name returns the class name of the execution point described by the invoking stack trace element. Okay. String get file name returns the file name of the execution point described by the invoking stack trace element. Then get line number returns the source code line number of the execution point described by the invoking stack trace element. In some situations, the line number will not be available, in which case a negative value is returned. String get method name returns the method name of the execution point described by the invoking stack trace element. Integer hash code returns the hash code for the invoking stack trace element. Boolean is native method returns true if the invoking stack trace element describes the native method, otherwise it returns false. String to string returns the string equivalent of the invoking sequence. Then enumeration. Enumerations were recently added by the Java language. Enumeration is created by using keyword enum. All enumeration automatically inherit the class enum. Enum is a generic class that is declared as shown here. Class enum E extends enum E. E stands for the enumeration type. Enum has no public constructor. It defines several methods that are available for use by all enumerations which are shown in following table. Okay, so these are the methods. Protected final object clone throws clone not supported exception. Invoking this method causes a clone not supported exception to be thrown. This prevents enumeration from being cloned. Okay. Then final integer compare to compares the ordinal value of two constants of the same enumeration, returns a negative value if the invoking constant has an ordinal value less than is 0 if the two ordinal values are the same, and the positive value if the invoking constant has an ordinal value greater than is. Final boolean equals object returns true if object and the invoking object refer to the same constant. Then final class E get declaring class returns the type of enumeration of which the invoking constant is a member. Then final integer hash code returns the hash code for the invoking object. Final string name returns the unaltered name of the invoking constant. Final integer ordinal returns a value that indicates an enumeration constant's position in the list of constants. String to string returns the name of the invoking constant. This name may differ from the one used in the enumeration's declaration. Static T extends enum returns value of class T E-type string name returns the constant associated with name in the enumeration type specified by E-type. Okay. So now we will see character sequence interface. The character sequence interface defines methods that grant read-only access to the sequence of the characters. Now we will see those methods. This interface is implemented by string, string buffer, and string builder. Okay, so for character sequence is nothing but group of characters or sequence of characters. So that it is implemented by string class, string buffer class, and string builder class. It is also implemented by character buffer, which is in the Java Neo package. Okay, now we will see that package later. Then comparable interface, object of classes that implement comparable can be ordered. That means classes that implement a comparable interface contain objects that can be compared in some meaningful manner. Okay, it is compared, they are compared in some meaningful manner. Okay, so whatever classes that implement comparable interface, that means the classes of the objects of those classes can be compared in some meaningful manner. Comparable is generic, and we will see this like interface comparable T. T can be replaced by any particular type. Here T represents the type of objects being compared. The comparable interface declares one method that is used to determine what Java calls the natural ordering of instances of the class. The signature of the method is shown here, integer compare to T object. Now we will see the methods. Character at integer idx returns the character at the index specified by idx. Integer length returns the number of characters in the invoking sequence. Character sequence subsequence, integer start idx, integer stop idx returns a subset of the invoking sequence beginning at the start index and ending at the stop index 1. String to string returns the string equivalent of the invoking sequence. This method compares the invoking object with obj. It returns 0 if values are equal. The negative value is returned if the invoking object has a lower value, otherwise a positive value is returned. This interface is implemented by several of the classes already reviewed in these sessions. Byte, character, double float, long, short, string, and integer classes defined compared to method. Okay. That's the next chapter. We will see objects that implement this interface can be used in various collections. Now we will see appendable interface. Objects of a class that implements appendable can have a character or character sequences appended to it. Okay, so those objects can be appended with a new character, single character, or a group of characters. Okay, so these are having three methods: appendable append, character ch, appendable append, character sequence characters, appendable append, character sequence character, integer begin, integer end, and three of them throws the input output exception. The character ch is appended to the invoking object. Second is character sequence characters is appended to the invoking object. The third form allows you to indicate the portion specified by begin and end of the sequence specified by characters. In all cases, reference to the invoking object is written. The iterable interface. Iterable must be implemented by any class whose objects will be used by the for each version of the for loop. Okay. So iterable interface is like this can be iterated. This can be continued in the loop. Okay. So loop can be anything. So here what it relates to for each version of the for loop. So iterable must be implemented by any class whose objects will be used by the for each version of the for loop. In order for an object to be used within a for each style of for loop, this class must implement the iterable interface. What is the declaration? Interface iterable T. Here T is the type of object being iterated. It defines one method iterator, which is shown here. Iterator T, iterator, it returns an iterator to the elements contained in the invoking object. Next is readable interface. Readable interface indicates that the object can be used as the source of the characters. It defines one method called read, which is shown here. Integer read, character buffer, buffers, throws input output exception. This method reads character into buffer. It returns the number of characters read or -1 if an end of file is encountered. Okay. Readable interface, first of all, indicates that object can be used as a source, can be used as a source for characters. Okay. So characters, those can be read. It defines one method called read, which is shown here, and it throws input output exception, and these characters will be stored, reads character into buffer, and it returns the number of characters read or -1 if end of file is there. Okay, so sub packages, we will see some more sub packages. Java Lang annotation, Java Lang instrument, Java Lang management, Java Lang reference, Java Lang reflect. Each is briefly described. We will see Java Lang annotation. Okay, so these are the sub packages of the Java class, Java program. Java's annotation facility is supported by Java Lang annotation. It defines the annotation interface and the element type and retention policy enumerations. Okay, what it relates to? It defines first of all annotation interface and the element type and the retention policy. Two enumerations. Annotations are described in next upcoming sessions. Instead, you can define soft references to these objects. An object that is softly reachable can be reclaimed by the garbage collector if available memory runs low. In that case, the garbage collector sets the soft references to that object to null. Otherwise, garbage collector saves the object for possible future use. A programmer has the ability to determine whether a softly reachable object has been reclaimed. If it has been reclaimed, it can be recreated. Otherwise, a object is still available for reuse. You may also create weekend phantom references to objects. Okay. Then reflect. Reflection is the ability of the program to analyze itself. Java.lang reflex package provides the ability to obtain information about field, constructor, methods, and modifiers of the class. So program will analyze itself. It can see or it can reflect itself as a mirror. So what it can analyze? It can analyze its own fields, it can analyze its own constructors, its own methods and modifiers. Among other reasons, you need this information to build a software tools that enable you to work with Java Beans components. Okay, Java Beans we have not seen yet, so we will see them in upcoming session. The tools use reflection to determine dynamically the characteristics of the component. Okay, reflection was introduced in chapter 12 and is also examined in chapter 27. Java.lang reflect defines several classes, including method, field, and constructor. It also defines several interfaces, including annotated element, member, and type. In addition, the Java.lang reflex package includes array class that enables you to create and access arrays dynamically. Okay, so now in this way we have completed the complete chapter exploring Java.lang package. This was the session 5, I think, video 5 for this theory part. In the next session, I will try to cover all the programs that we have seen in this, all the PPT, okay, one by one, to understand and to learn. And most important thing that I have already told you, that is you have to practice. Okay, so meet you in the next session for the practical examples. The same examples those we have seen in theory part, we will see them as a practical, we will run them and we will try to understand and learn them. Okay, so meet you in the next session. Thank you so much.